Okay. Current assert happens very quickly. We start in 0, then we do 1, then we jump to 2, which immediately finds this maximum. And then the fourth degree polynomial fit immediately jumps to this minimum here, like immediately. Including the assert. Just run it again. So 0, 1, 2, and we found it, and crash. What is the reason? Yep, it even thought it was a local extreme as well. I think I need more context. So this is algorithm.cxx crashing in 1012. Oh, it's pretty much at the top. So the handle local extreme is called when we find that if we fit a cubic polynomial and then jump to the minimum of that cubic, then we hardly move position, which would, for example, happen when the derivative is already 0. It kind of looks like it. Derivative is 0, so if you fit any cubic through this point, then it's going to have a minimum right there. Well, fitting through points and fitting the derivative. So the derivative has to be 0, aka it is the minimum. And then this function is called. And state is not equal to extra sample. Let's just find extreme or something. So we jump over this to here. Comments are good. Remember the node containing the cubic that found this extreme. So the cubic that we did fit, that has its minimum close to the last point, is cubic used, and we stored it in the last extreme cubic. Which means that was the minimum of that cubic is then the minimum that belongs to this point. And cubics are defined by 2 points plus their derivatives. And it prints the label is, it's just equal to the left node, which should be 2, because we have probably fitted, that's the only thing that's possible, fitted the cubic through this new point, and then, the closest one, there's nothing on this side, so that would be 2, which is also an extreme. So basically we fitted the cubic that has a maximum here and a minimum there. And the left node is called 2, therefore the cubic is called 2. And should have printed it here. And it did. Don't see anything wrong with that yet. The local extreme cubic may not contain an extreme of the opposite type. Well, it does. Sample node has only one local extreme pointer. Well, that's the reason. And it's not allowed to contain an extreme of the opposite type. So if this fails, then we need to insert an extra sample to cut the last extreme cubic in two. So it is simply test as the last extreme cubic, also an extreme of the opposite type, so a maximum. And it does, because we start at 2 and we end in, this is probably 3. And we also have a maximum, because the maximum of this cubic is included with the 2. So the 2 is a minuscule, is exactly at or a tiny little bit to the left, not to the right, otherwise it would not have been included. And we get here. Apparently, last extreme cubic contains 2 extremes. I agree. They should occur in the expected order. If last extreme cubic equals chain last, that's not the case. This should be chain last, I think, or maybe that one was not added yet. Yeah, now I need to know how a chain looks like. And the new point was already added, I think. Well, if it was added, then that is chain last. Let's just print chain last. Print chain last. That's 3, yeah, so it was already added. You know, only see 0, 1 and 2 plotted yet, but then this is going to be 3, so 3 was already added to the chain and it's added at the end for obvious reasons. Now, the chain is ordered by W value, so it's the rightmost ones, therefore it's at the end. But I think last points to actually the last one that was added, so that is also 3 then. At any rate, it was added. And the W value is 4.5. Yep. It's 4.5 is here. Oh, you do see the 3. The level was already added. Okay, well. If the last extreme cubic equals chain last, then we have case 3 or 4. Well, that's not the case, so we have case 1 or 2. Let's verify that. So we have one of these cases. The star means the last extreme cubic. And B is the one that is close to the new extreme. That is the extreme that we found, and B is close to it. And yep, A is far away on the left. So this is 0.2, this is 0.3. We don't know yet if it is minuscule to the left or the right, or maybe exactly on top of it. So it's either 1 or 2. Apparently, a last extreme cube contains extremes. They should occur in the expected order. If last extreme cubic equals chain last, then we have case 3 or 4. In which case, the next extreme type B must be on the left of the opposite extreme. That is also part of BA. Otherwise, now I start paying attention. We have case 2 or 1, and the next extreme type must be the extreme in AB that is on the right. Well, I think that's correct. On the right. Yeah? So we have extreme here, we have an extreme here. And the extreme on the right is the one that we just found, which is minimum, which should be the one that we were looking for, which is stored in this variable. That is minimum. Yeah, I would say the comment is correct. Then maybe the assert is wrong. Yes, extreme order. What this means is last extreme cubic type. Let's print it. Oh, what? This means that this cubic only has a maximum. And no minimum. Well, suppose that would be correct. In this case. So it includes the maximum on this side, but the minimum is not included. Let's verify then that. So the question now is, where is the actual local extreme and where is B? Isn't the location of the local extreme is assumed to be W, I think. And the coordinate of, that must be the same thing. No, this is about the cubic, the minimum of the cubic. It just depends on the derivative. What is the derivative of 0.3? That is the last time we entered. Yeah. So the derivative is negative. That means that the jump point was on the left. Then we have a negative derivative. So the extreme is a little bit further. So if we are negative and we want to go to 0, then we have to go to the right. So it is indeed case 1. which means that only the maximum is contained in it. Which, by the way, is also only possible if the derivative in the point 2 is positive. Let's see if we can find that back. That is the last extreme cubic, maybe. That is last extreme cubic. It's a positive derivative. Yeah. So because the derivative of point 2 is positive still, we are on the left of this point. So the maximum is included. So the type is correct. It is a maximum. In which case, has extreme order is going to return false, always. That's why the assert fails. Because the problem here is that I'm testing that it has the opposite maximum, therefore it has a maximum, but it does not have a minimum. So it says here, the local extreme cubic may not contain an extreme of the opposite type. I think that is correct. So this is indeed not allowed. But if then it does not really include the local extreme that we found, then this is going to fail. I think I just have to treat case 1 differently. This would be case 2, and case 1 means that this is true, but we don't have next extreme type included in it. No crash. Also no. We found it yet? Probably because it just delays. Well, we can't say that we found this local extreme yet, because then we have to point to some cubic, and the only cubic that we have is the one that contains a maximum. So instead we should be trying to cut it in two now, which is probing somewhere between 4 and 4.5. It's like probably, I don't know, 4 or something. This value. Yep. 4.25. No. Should I hit space, I guess? Yep, there it is. And now we zoom to this point. And thank God we immediately find it then. Okay, seems to work then. You continue in the same direction till you find this point. Wow, again an ASSERT, really. What is it this time? Forced assignment is required to be in range. Well, the range is minuscule. It's like both arrows are like in the top here. Must be between 7 and 9. And 7 better be larger. No idea how I can. Oh, of course I can. Just print it. Duh. To the right of is smaller. So yeah, to the right means larger, so it must be larger than this value and smaller than this value. That is possible. And the requested value is outside of that range and not a little bit. That's why we assert. Curious. And I'll get extra sample. Why would an extra sample be required to be in a narrow range like that? The whole point of the extra sample is to not be super close, if you ask me. It's close enough. Seems again that the assert is not really correct here. You just see the extreme plus a scale step, which might be way larger than the range. Yep. So the extreme is in range, but we only have 2 samples. We need a third sample to fit a 4th degree polynomial correctly. And it decides to take a sample at 5.06. I see no problem with that at all. So I would say that in the case of this handle get extra sample, that's just a whole. Not enough comments. I wrote this comment and now I don't know why. Why is that required? It's just nonsense. This case is nonsense, so I don't understand it. Let's see, this was something quite big in range. Just not true. It's being called from here. It's the only place where we call it. You know, I'm not even using the fourth degree polynomial, not even fitting it now. Oh, sorry, that's nonsense. Ah, nonsense, nonsense, nonsense. Why am I not seeing my fourth degree polynomial fit? So look, not enough samples to fit a fourth degree polynomial. Asking for another sample at 5.06. Okay, so this is the first time. No clue. There it is. Okay, so nothing disastrous did happen. Now it decides to jump to the minimum of a cubic fit. And nobody knows where the fourth degree polynomial goes to, but it looks like minus infinity. So if we look at the output. So we were here. Then we did get a new point. Getting extra sample and the local extreme again. Number of samples within scale range 3, including a new one. Extreme type toggle to a minimum fitting fourth degree polynomial using those samples. Approximation, derivative, quotient, second derivative. And the last extreme plus step. Entering scale step right. With no other usable local extreme using extrema. Okay. So it goes to minus infinity. The thing does not has a maximum but no minimum. Using step in both directions, set opposite direction to undefined value. What? That's not good. It is totally wrong. Yeah, what the fuck? And it is supposed to be set, it's just not set. Oh, because this is false. This is set to false, and therefore we don't have to set it. Which means that there is no reason to print it. Bloop. Same thing here, see? So it's set to false and then just not printed. And then we get initialize range. Minus 5.7. Oh, sorry. What? Yeah. Using a minimum of left cubic because the right one does not exist. So anyway, that's why we have a cubic here, because the fourth 3 polynomial just goes to minus infinity. So it's using the cubic that goes through, I don't know, 8 and 10, I guess, or something. We jump to here, and then we find this, which is worse than that one. So we have to explore to the left of that. But there was already a found maximum here, therefore we want to find not a maximum left of this, but we want to find a minimum left of 0. And there was already a point here, only going down, so the range is set to 1. So we want to find a minimum now left of 1. Which causes us to probe 13. Some reason, and then jump here, jump here, jump here, and found it. And this is also worse than that one, so this is the final answer. Which means we jump back to another probe during the finish, and then stop. Now we found a global minimum with an extremely small derivative, so yeah, that's actually the correct, very precisely the correct value. Try this again after recompilation. It still does the same thing, of course, but well. Okay. Let's try one with a random seed. Gee, wow, the thing just can't just really. Why? This is never okay. I mean, not like the 100th. No, every new random function I run into some kind of problem. This time not even an assert. It's a sec fault. Really. Okay, well, it is a weird pointer. Ending on 7. Which is odd, so that would only be correct if the size of the unique ID thing is 1 character big, which is definitely not it. Definitely not the case. Yep, so this pointer is a nonsense. This pointer, the label is nonsense. The left of is nonsense. It's really nonsense. Initialized range should assign it, because that's what it's supposed to do. Assign left off and right off. According to what is being drawn here, is left all is already assigned before. At least once. So we do going to set a breakpoint on an initialized range for now, and I'll run it from the beginning. Oh, oops. It's a different one. Hello, Rahul. Yeah, this is the nonsense you get if you ask GDB to print left off, which is just designed to end. It just dereferences it for you. Well, that's not even possible. I need better music. This is insanity. Okay, yeah, well, I'm just gonna set a watch point on the value of left off and then see where it gets corrupted, I suppose. Print the address of left off. I have no idea what the size is of that cons iterator. Probably 8. Guess the watch point doesn't do this stupidity, so I can just do a watch. Well, there it is. Change from end to something that we can't read. No, it says that we are here, but maybe we just did this. Yep. Aha. So I'm calling is cubic on end, which is not allowed, and by, well, 50% chance, and apart from that it should have crashed. So that returned a random true, and then we called next node, which also returns random stuff, but in this case more noticeable than a boolean. Let's have a closer look at this code here. Oh, too difficult. Let's just set a breakpoint here and then think about it using the actual values that happen. So this is line 1775. Suppose I should delete my watch point. Yeah, that's breakpoint 1. Just continue. Okay, now we are here. So which case do we have? I'm dereferencing left node, so that should already have, should be pointing somewhere. And it isn't. Wow. Seriously? Where did the left node come from then? Left node. Left node can totally be a chain end. Is a chain end. Yes. What does that mean in this case? So right node is defined then. It's 2. What is the coordinate of 0.0 then? Is this 0.0? Doesn't look like it. Point 0. 0 is exactly 4. Okay, so 0.0 is exactly 4. Extreme W is 3.9669, which is therefore a little bit to the left of 0.0, very little bit. which means that we should find 0 as the larger node. And then right node is the node on the right of extreme, that is then 2. 1 is over here. So we go back to this thing here, now we see find larger, should have found 0.0. Sorry, right node should be 0.0. Tricky, yeah, hi. My objective is to find, well, this in the title of the video. I'm designing an accelerated gradient descent algorithm. My objective is depending on the time scale. So my objective of today is to fix this bug. Right now this chain larger, that should be 0. Zero is at 4, and we've searched for extreme W, which is really a little bit smaller than 4. Let's start over in initialize range. Leave this, switch back here, run again. So it is at the start of initialize range. Next. So it's 3.967. It's not even that close to 4. It's at both end. Find larger. This should find. We're just going to step into it. Find larger 3.9. We are not allowed to be empty. Larger is set to last. That is 2. Okay. Which has a value of 3.96. What? 3.97, I mean. Oh, 3.9. Oh, what? Oh, okay, I was looking wrong. Then on the right, we are, okay, we are on the, I thought we were a little bit on the left of 0, but we are even on the left of 2. Just, I don't know, this is smaller than I thought. But this should be, yeah, well, still, I don't know, apparently. I mean, last is 2, so 2 is 3.97. So extreme W is on the smaller, so yeah. It is on the left of that. So the nearest point on the right is indeed 2. So we find 0.2 with 3.97, which is larger than 3.966. And then we assign the right node to that. So now the node on the right is 2. And the node on the left does not exist. Because this is at the beginning. 2 is at the beginning. So left node is equal to chain end. And because right node is equal to chain begin. Then we say if left node is unequal chain end and is a cubic, but this is just debug check, so we skip that. It's H direction, well we're going to the right, so I think that's a yes. Yeah, and now I'm dereferencing left node. What the hell? For example, I'm looking for a maximum. I think we are looking for a minimum, but okay, the idea is the same. It could be like this. But it can't be, it isn't like this, because this says that there is a left node. We don't have a left node. What is lost extreme cubic set to anyway? Also 2. That means, I think it is that we are looking for a maximum. I think we just found a maximum. I don't know. It's a bit. I think we found the maximum. So we found the maximum, and we're very close to it as well. Yeah. Okay. Sorry. Extreme W is just you know, close to the last extreme cubic. This case, and we are on this side. Although now we're talking about a minimum here. Well, just missing. The picture is missing. The situation we have is this one, but then without that left node exists. See if I understand why. So here it has to exist, because last extreme and cubic just exist. So this cannot not exist, because right node is the first. Can't be the first, because at least last extreme is still on this side. And here it can be, because if last extreme is equal to the right node, why would there be a pointer on the left side? So this might not exist. And in this case, yeah, the right node might not exist. I think this is the same thing as above here, but then without the right node. So it's 100% symmetrical, as it should be. I'm gonna swap these two. Finally is then no longer the case, but okay. So here you see that these images are just totally the same. Left node, extreme W, last extreme cubic, the maximum that you want to find, etc. Just right node is there or it is not. And this case left node is not immediately on the left of the right node, however. So that's interesting enough. How the hell did we find that? I think we found that by it is on the left of the right node, because and is also something, and then if you decrement the iterator you get the last thing, which is then left node here. So left node was determined like that. Than the previous right node. But that means that the right node is not chain begin, and it is not chain begin because we asserted that the list is not empty. So right node equals chain end, and it's not equal to chain begin because chain begin is not equal to chain end. Okay, so this Boolean expression must be false if left node equals chain end. Yeah, because I want to set it to a right node in this case. We want to set it to right node in this case. We want to set it to left node in this case. And we want to set it to left node in this case. So whether or not something exists doesn't really matter. We only wanted to set it to left node if one of these cases, which means that left node exists. Right node possibly does not exist. But then there's two possibilities. Either this case where right node does not exist, in which case left node is not a cubic. And the other cases where it is a cubic, and then we demand that the minimum comes first. Because there is a situation where left node exists and is a cubic, but the maximum comes first. And that is this case. So we don't want to select left node in this case. So left node must exist and either not be a cubic or the extreme order is correct. And then we pick left node, otherwise you pick right node. And this just doesn't change. And then the painful thing is that, yes, we do it all over again. No. Hey, what? This looks different. Don't tell me I already did it in this case. It's exactly the same as what I just did. Left node is unequal chain end, and either it's not a cubic or the extreme order is correct. Wow. But I'm pretty sure there's still something missing here. Let's move this one up as well. Yeah, this is the extra comment that led to this. Somehow already ran into it, I guess. Just leaving the comment there for now. Move this up. And then I want to copy my previous work from that order does not exist. So while we are talking about left node does not exist, because it does exist here, it does exist here, does not exist here, okay. It does exist here. So if it does not, if the left node does not exist, we want left off to be set to right node. So if it does not exist, then this is false, and it will be big right node. In this case we pick left node. In this case we pick left node. In this case we pick right node. And in this case we pick right node, I bet, yep. So left node must either not exist or it must exist. Be a cubic and have a certain order, namely first a maximum and then a minimum, as opposed to where it exists as a cubic and has it in the different order, which would be this case. So that sense it is the same Boolean expression. Except probably this is flipped. Or these, I don't know. It's correct this way. Then we do that, and that should still be correct. Yeah, let's just delete all breakpoints because I believe it will run. Okay, so we go to this minimum and then to the next, I guess, the next maximum and the next minimum. And this one is worse, so we go back and then find this one and then we are done. Finding that one is the last, it's the best. Finally, it worked. Let's run it again. Without a seed, so some random function. Ah, you gotta be kidding me! It's like 5 times on a row that a new function leads to an assert or a crash. The number of bugs is still infinite, it seems. Yeah, I'm leaving though. I'm going to visit my dad and I'm already 10 minutes late. Damn it. I wanted to go for a walk today. It's a 40-minute walk. I don't want to arrive after 3, so... I don't know. I'm gonna be late, I guess.